Launching instances in the correct subnet is crucial for a secure and functional AWS environment. Auto-scaling groups, or ASGs, make this easy. When configuring your ASG, pay close attention to the subnet settings. You can specify a single subnet or multiple subnets across different availability zones for high availability.
Ensure the selected subnets align with your application's requirements. Consider factors like network traffic, security groups, and routing. Remember that instances launched in a subnet inherit its attributes. Proper subnet configuration during ASG setup prevents connectivity issues and potential security vulnerabilities. It ensures your instances have access to the right resources and are deployed in the intended network environment.
GitLab CI/CD pipelines are powerful tools for automation. However, troubleshooting YAML files can be challenging. Syntax errors are a common problem. Ensure your YAML files are properly formatted and indented. Use a YAML linter to catch errors early on.
Another issue is incorrect variable usage. Double-check that you're using the correct variable names and syntax in your CI/CD jobs. Look for typos or inconsistencies in your variable definitions. Access issues can also cause deployment failures. Verify that your GitLab runners have the necessary permissions to access your deployment environment. Check AWS IAM roles or access keys configured for your runners. Lastly, ensure your deployment scripts are error-free. Use debugging tools or logging to pinpoint the source of any failures within your scripts.
Access keys and permissions are essential for interacting with AWS resources. If you're experiencing deployment issues, start by verifying your access keys. Ensure they are correctly configured in your CI/CD variables or environment.
Next, review the IAM policies attached to the user or role used by your deployment process. The policies should grant the necessary permissions to perform actions like launching instances or uploading files to S3. Use the IAM simulator to test and validate your policies. This tool helps you understand how your policies affect access to specific AWS services and resources. Remember to rotate your access keys regularly for security. Store them securely and avoid hard coding them in your code or scripts. Section 4. Deploying a to-do application with Ansible, a practical example.
Let's deploy a simple to-do application using Ansible to illustrate its power. First, define your infrastructure in an Ansible playbook. This includes provisioning a server, installing web server software, and configuring networking.
Next, create tasks to deploy your to-do application code. This might involve copying files, installing dependencies, and restarting services.
Ansible allows you to manage configurations and automate deployments efficiently. It uses a simple, readable language and leverages SSH for remote execution, making it a popular choice for infrastructure automation. This example demonstrates Ansible's practicality in deploying real-world applications.
Its versatility and ease of use make it a valuable tool for managing complex deployments. Section 5. The importance of key pairs for SSH access.
Key pairs are essential for secure SSH access to your cloud instances. They consist of a public key and a private key. The public key resides on your instance, while you keep the private key secure.
When you connect to your instance, your SSH client uses the private key to authenticate with the public key on the server. This eliminates the need for passwords, providing a more secure way to access your instances.
Compromising a password can grant unauthorized access to your server. Key pairs, especially when combined with strong passphrases, offer a higher level of security. Remember to store your private key securely. Never share it publicly or expose it in insecure environments.
Section 6. Creating and using key pairs with Terraform.
Terraform simplifies the management of cloud infrastructure, including key pairs. You can define a key pair resource in your Terraform code and specify its properties.
Terraform handles the creation of the key pair and provides you with the public key.
You can then save this public key and use it to launch instances. When launching an instance, reference the key pair you created in your Terraform code. Terraform will ensure that the instance is launched with the associated public key.
Using Terraform for key pair management streamlines your workflow and ensures consistency across your infrastructure.
It integrates seamlessly with other Terraform resources, making it a powerful tool for managing your cloud environment.